Hey, hello to all my great students out there. Dr. Mandis here, coming at you today to talk to you very briefly about the percent composition by mass. I can remember as a student learning this and thinking percent composition by mass, like it was a different way to do it or something like that. It's kind of, and it still intimidates students to this day. It's just the phraseology of it. You go, I don't know, what if I don't know the masses and all this sort of stuff, and you have to assume the masses. It's a lot easier than people, I swear, sometimes teachers just want to make things sound difficult so they can be smart. This isn't difficult. I don't mean to say that you're stupid if you don't get it. I'm not saying that at all. I'm just saying of all the junk we've been doing, this is a lot more straightforward. I guess more straightforward is better than is what I should be saying. So basically, this all is off of the molar mass. If you can handle doing a molar mass calculation, you got percent composition down. Molar mass, don't think of it as the mass. A lot of students shorten it. Instead of saying molar mass, they say the mass on the periodic table. You're getting the molar mass, the mass of 1 mole. Okay? So molar mass, you add them all up, and I did the example, if you got 2 H atoms and 1 O atom, then that's what you're going to have right there. You know what I'm saying? You add them up, hydrogens are 1.01, oxygen 16, you can get a molar mass of 18.02. That means you got 18.02 grams for every 1 mole. Okay? That's all it means. All right? 1 mole is 18.02 grams. All right? When you do percent composition by mass, the thing that you're assuming is you have 1 mole, so you can use this mass. Okay? And what you're really saying is of this 18.02, what percent was H, what percent was O? Well, what numbers did we use to add these things up? Okay? Well, we added two H's and an O. So for H, it's going to be 2 of the H's over the total. For O, it's just going to be 1 O over the total. Some students say, hey, why is it 2 for one and 1 for the other? Because there are 2 H's in water and only 1 O. Okay? This right there is the most often missed thing. Any level of chemistry, students just get focused on it's the atom over the total. It's not. It's that all of it. Okay? So if you did that, you'd have to double the molar mass of hydrogen, but only one of the molar masses of oxygen, 2 there, 1 there. Okay? And do the total. Okay? That what you have, 2.02 over the total. 16 over the total. If you notice, I switched units. And one I did atomic mass units in the red. On the green, I did molar mass units. And I did that on purpose because some teachers like to start percent composition by mass when they do the periodic table. And if you're somebody like that and you're saying, what the heck's a mole? You're just adding things up off the table. Okay, remember, a percentage is always what you're interested in over the total. In this case, we're interested in those 2 H's over the total. In this case, the 1 O over the total. Alrighty. Here's another example. Percentage of calcium chloride in water. You got CaCl2. Percentage of calcium chloride by mass. Sorry. Alrighty. You got 1 Ca in calcium chloride. So you're going to have 1 Ca over the total of calcium and chloride. Again, you can use atomic mass units or the gram per mole, but either way, you're going to get 36.11. If you are the more experienced student, you kind of want to go by the mass of 1 mole gig, and you're going to be really good at calculating molar masses. So you can just get the grams of each and do the percentage. So let's go back to that example. If you look at it, the molar mass is this number on the bottom. The molar mass of calcium chloride is 110.98 grams per mole. That means if you translate it, it's kind of like saying, bananas are $2 per pound, wickedly expensive for bananas, but if they're $2 per pound, that means 1 pound is the equivalent of $2. It's grams per mole, okay? So you got 110.98 grams for every mole, alrighty? Of that, this 40.08, this top term is due to calcium. So you can just do the percentage off of that. So if you're really adroit at calculating molar masses, it's just the molar mass of the dude you're talking about, the total of all that over the total. The thing that people miss is when you have that coefficient, like if it had to be doubled for some reason. Like if you had calcium phosphate or calcium phosphide, Ca3P2, you would have 3 of those calciums. So it wouldn't be 40, it'd be 3 times 40.08, so it'd be 120.24. Cool? Alrighty, so that's it for percent composition by mass. It's really just that straightforward. You have a lovely day now. I'll talk to you later. Take care.